Hello, I'm Mike McCulloch. So today I thought I would talk to you about possibly the most photogenic evidence for quantized inertia, which is Hoag's object. So this was discovered by Hoag in about 1950, and you should be seeing a picture of it right about now. It's composed of a yellow center and blue stars in a ring around it. So this is what's known as a ring galaxy, and there are quite a few of these actually. It's thought that about 0.1% of galaxies are of this kind, and there are actually two of them in this picture, because there's Hoag's object, and then behind it you might be able to see a very small ring which is also a ring galaxy. The great thing about Hoag's object is that it's facing us directly, so it's a beautiful ring shape. So the interesting thing about this is that if you work from the visible matter only, the matter that we can see, the lit matter if you like, and then calculate the mass at the center, and then you work out what gravitational acceleration the stars at the edge must be feeling, you get, surprise, a number very close to 2 times 10 to the minus 10 meters per second, which is exactly the same as the edge acceleration of every other galaxy, of course. And that's a fundamental prediction of quantized inertia, that there is a minimum acceleration in nature which is of this value. And this galaxy illustrates it incredibly well, because the edge stars are rotating at about this acceleration. So this is very interesting. So how might this have formed? Well, in quantized inertia, what might have happened is that the stars went out from the center, and eventually towards the edge, the acceleration, as they move away from the center, their acceleration reduces until they get down to this minimum value, when their inertial mass collapses because the underwaves they see are too long to fit within the cosmos, and so they now have much less inertial mass, and so they're pulled back far more strongly towards the center. And so this predicts that there should be a ring, just as we see, where the stars reach this minimum acceleration and cannot go beyond it. So this is a very nice illustration of quantized inertia, and you can imagine it applying in other circumstances as well. For example, does the solar system have a similar sort of Oort cloud around it? So there is supposed to be an Oort cloud around the solar system anyway, for other reasons, but quantized inertia predicts a particular radius for it, and it's a bit closer in than you would normally expect. So that's Hoag's object, possibly the most photogenic of all the evidences for quantized inertia. And I hope you've enjoyed this short. Please do subscribe at my Patreon if you want to, and I look forward to seeing you next time. Goodbye.